Okay, so we're going to go over the compound angle formula, and there's quite a few of them. They refer to, usually, say you have something like sine A plus B, and essentially you're adding two angles together, and they give you a lengthy formula that goes along with this that you have from your textbook. And then there's cos plus A, and then there's subtracting 2, and tangent also. So you have at least 6 of them to essentially memorize. What we're going to do is we're going to find the exact values of these. So this will be question 1 and question 2 by actually breaking these into compound angles. So everything we're going to do is going to be related to our special triangles. So we have our two special triangles. Do you remember them at all?
Yeah.
Yeah, okay. So help me out. If this is 90 degrees and this is 45, that's not 45. What's the other angle in there?
45.
And what are the measurements?
1, 1, 2.
Yes. And what are they as in radians?
In radians?
Mm-hmm. Do you remember? Okay, we can convert them to radians, or if you remember just quickly, a fast way to always think about it is, say we're on this plane here. Do you know what 90 degrees is?
It's pi over 2.
Pi over 2, great. So 45 degrees is how much of 90?
Oh, it's pi over 4.
Yeah, exactly. Okay, so that's a fast way to remember it. We got our pi over 4 and pi over 4. Our other one, this being the larger angle, is 60 degrees, 30 degrees. What are our measurements of our sides?
It's 1, 2, root 3.
1, 2, and root 3. Good. What are the angles as radians? I guess this is root.
So 30 is pi over 6.
Yep.
And 60 is pi over 3.
Good. Or 2 pi over 6, right? Same thing. Okay, so we're going to need those because we're going to have to refer back to them as we go through this. Now, the reason we want to refer back to them, and right now we're in degrees will help us, is because this question is in degrees. Okay, so we're going to focus on the degrees. The second one is in radians, so we'll focus on radians for that one. What we want to do is we want to actually break this number, because you see 15 doesn't occur in either of these special triangles. We want to break it into two compound angles that would equal this, so that we could use our compound angle formula. So looking at these, what two angles can I use to create 15? There might be more than one option, but what angles could I put together, whether I'm adding or subtracting to get them? So if you look at the angles here, for instance, we have 45, right? How could I turn 45 into 15? What would I need to do?
Subtract 30.
Exactly. So perfect. Those are two angles that are in our special triangles, so we can use them. The goal is to create these angles in here using the essentially 3 that we have. Okay? Well, technically 90 is in there too, but those are the 3 that we have. So what we're going to do is that question, number 1, we're going to break it down to no longer is going to be cos 15, but it'll be cos 45 subtract 30. Okay? So now that we've done that, we're going to use our compound angle formula. For we're using two angles with cos. So the formula reads cos A subtract B is equal to cos A times cos B plus sine A times sine B, right? Okay, so this is our compound angle formula now. So we're going to use this to solve these. Okay, so A is going to be our 45 and B is going to be our 30. So we are going to plug these into this formula. So now what we have is cos 45 minus cos 30, or cos 15, is equal to cos 45 cos times cos 30 plus sine 45 times sine 30. Okay, these are multiplication. So each of these brackets we're going to replace with actual values. We're going to remember our primary trig ratios. Do you remember SOHCAHTOA? Yeah, so we have our SOHCAHTOA. Because our special triangles are both right angle triangles, a little much, let's go down just a little. Because they're both special right angle triangles, cos 45, well, cos is adjacent over the hypotenuse, right? So cos 45, well, if I'm at 45, adjacent is 1, hypotenuse is root 2, so I'm going to replace that with that fraction, 1 divided by root 2. Cos 30. Cos 30 is adjacent, which in this case is root 3, over hypotenuse, which is 2, so root 3 over 2. So we're going to go about replacing each of those with those fraction values. Okay, so this now reads, what do we say, 1 over root 2. That's our cos 45. And cos 30 was adjacent over hypotenuse, which is root 3 over 2. Plus sine 45 is, so 1 over root 2. And sine 30 is 1 over 2. Okay? So now we're going to use our fraction rules to essentially get the equivalence of these. So we multiply these through. We're probably going to want a common denominator after. And actually we're going to get one. So we multiply across. 1 times root 3 is root 3. And 2 times root 2 is just going to be 2 times root 2. We're just going to leave it at that. Okay? Plus 1 over, perfect, 2 times root 2. Well, now we have a common denominator. It's the exact same, so we can just add. So we now get root 3 plus 1 divided by 2 over root 2. And that's it. That gets us our first one. Okay. So now we've gone through this process. We'll go through the second one a little quicker. We'll jump back up to the top. No, page width. Okay. And up here, we have negative 5 pi over 12. Okay. This one's going to be a little harder to break down, but again, we want to break it down using our radians. Okay. So I need to create negative 5 pi with a denominator of 12. Well, one way that might help us is if I just tweak all of these triangles very quickly and make them all of a denominator of 12. Okay? So pi over 4, the equivalent of that would be 3 pi over 12 if my denominator is 12. Right? And the whole reason I'm doing that is because this one's 12, so it'll just be simpler for me to look at. Which means this is also 3 pi over 12. And this is actually going to be 6 pi over 12. Okay? This will be 6 pi over 12. This will be 4 pi over 12. And this will be 2 pi over 12. I just made equivalent fractions. Does that make sense so far? So now looking at these, what two can we combine to create negative 5 pi over 12? Looking.
2 and 3.
The 2?
Oh, wait. Negative?
Yeah, it's going to be a negative value. Let's check back here. They've given something there. Oh, they've done it like that. So what they've done here is we got to get to negative 5. So let's see if we can. Ah, okay. Another way you could do this is think of how we can add it up to 5. Okay. What 2 can we add up to 5? You said it. 2 and 3, right? We'll make both of them negative. We can do that because we know we're going to be in a different quadrant, right? Because of our CAST system. Oops. We have our CAST, right? Well, we'll use those two values. And so that relates to our pi over 4. And this relates to pi over 6, or in other words, 30 and 45. Okay, so we're going to use those two radians. We're going to use negative pi over 4 minus pi over 6. Okay, so we'll kind of jump to the next page here. We're going to have tangent negative pi over 4 minus pi over 6. Okay, we chose those two because we know we're going to create that. Then we got to use our compound angle formula. We're subtracting, okay, and the first one's a negative value when we go through it. So that one's going to be important. So anyways, let's write out the formula. Tangent A minus B is equal to tan A minus tan B, all divided by 1 plus tan A times tan B. Okay? So what we're going to do now is we're going to replace all of the values in here. This will be our A. So A is technically be a negative term. And b won't be. This is the actual term for b because this is the subtraction that gave us this subtraction formula. Okay, so when we plug things in, we just have to recall that certain things will be negative. So tangent, let's do this in black. Tangent negative pi over 4 minus tangent pi over 6 divided by 1 plus tangent pi over negative pi over 4 times tangent pi over 6. So again, what we're going to do is we're going to replace each of those values with our special triangle. So I'm going to briefly draw them on the side just for reference. Okay, this we'll say is our 60, I know it's not to scale, 30, 90. This is our 45, 45. In other words, this was our pi over 4, pi over 6, pi over 3. These are the two we need, right? 1 root 2, 1 root 3, and the number 2. Can you read all that? Yeah, that makes sense? Okay, so we have our values. Let's replace them with what we have here. So tangent pi over 4, okay? It's going to be a negative value because we have a negative here. So tangent is opposite over adjacent, which is 1 over 1. But because we have the negative value, essentially our number is just going to be the number 1. So we have negative 1. Subtract tangent pi over 6, well that's 1 over root 3, right? 1 over root 3 divided by 1 plus, and we've already figured that one out, right? So it's going to be negative 1 times 1 over root 3. So we'll work these out. Let's work out the bottom here. This is going to be 1 subtract, negative 1 minus 1 over root 3 divided by 1 minus 1 over root 3. Okay. We'll break this into, I guess we'll get common denominators, put them together, and then work from there. So because these are root 3's, I'm going to turn both of the 1's into denominators with root 3. Okay, so in other words, that's going to be negative root 3 over root 3. Does that make sense? That's the equivalent of 1.
Okay.
Over root 3 over root 3. We've replaced 1 with that. The reason it's 1 is because root 3 divided by root 3 would still be the number 1, right? Now that we have that, we have common denominators. So this becomes negative root 3 minus 1 all over root 3. And then that is all above. This one's a little tricky. There's a lot of fractions to it. That is all above root 3 minus 1 all over root 3. Because this is a division sign, I'm going to rewrite this. Okay? And I'm going to rewrite it so that we're going to divide our fractions. So we have negative root 3 minus 1 over root 3 divided by, so it's the same thing as above. I'm just rewriting this. Root 3 minus 1 over root 3. Do you remember your rules with dividing fractions? We invert the second one and then change this to a multiplication question.
Yeah.
Okay, so then what's going to happen is we're going to have negative root 3 minus 1 over root 3. Root 3 over root 3 minus 1. Okay. When we multiply those, it's like distributive property. Okay. So we're going to distribute the root 3 times both things. So that's root 3 times root 3 is actually just the number 3. Okay. And then root 3 times negative 1 is root 3. Root 3 times root 3 is the number 3. And then minus. Something went funny there. Root 3. I think we've lost a negative somewhere. As I wrote this out. Towards the end, we shouldn't have gotten that, because that tells us the answer is 1, which isn't quite where we are. I guess we could have factored. The idea is that is the process to it, though. Okay, so I'm going to jump through and try to see if I can figure out what the answer is. But that's the process to going about doing this, really just converting everything to special triangles. Okay.